Hello class, this is section 3.8, the normal distribution. And recall in section 3.4 when we looked at graphs of quantitative data, we were looking at the histogram. And the histogram has some general shapes that it could take. It could be bell-shaped, it could be uniform, be right-skewed. Notice the tail here on the right is small and narrow. Or it could be left-skewed. Again, here the tail on the left is small and narrow here. Now these aren't all of the different shapes that a histogram can take, but these are some classic shapes that histograms often take. Now the bell-shaped graph of the histogram is one of particular importance. It's going to be called the normal distribution. Now the histogram itself isn't the normal distribution, but we can approximate the histogram with a smooth curve called the normal curve. If we look at some examples of a histogram that's bell-shaped, here in example 3.8.1, I've got a table of 50 IQ values. And if I sort these IQs into different classes, here the class width is going to be 7 units. And I do this from 63.5 all the way through to looks like 133.5. So here I've got 10 classes, each class of width 7 units. And notice the class boundaries are at half integer values, 63.5, 70.5, because all of the data values are in whole numbers. Now here, because there are 50 data values, all of the frequencies should add to 50. And notice we see the most frequently occurring data values occur in the class of IQs between 91.5 and 98.5. And then it looks like the frequencies go down as we get further away from this most popular class. On the low end, it's small at 2, and at the high IQ, it's also low here at 1. So we can convert these frequencies into relative frequencies by simply dividing each frequency by the sample size, and in this case the sample size was 50. And so here 2 divided by 50 is 0.04 or 4%. Again here 2 divided by 50 is 0.04 or 4%, and continuing in this fashion we get the relative frequencies for all of the different classes. So the class that had the most data values within it had a relative frequency of 22%. So 22% of the 50 data values fell into this class. So now if we take this frequency table or relative frequency table and we make a histogram of this particular table of data, we'll get something that looks like this. So here, write a histogram. And notice here the most frequently occurring class, which is 91.5 to 98.5 IQ, has the tallest bar in the histogram. Now I don't have any units on this, but the horizontal units would be IQ. And then for each of these tick marks, I would put one of the class boundaries, 63.5, 70.5, etc., until I finished out with 126.5 and 133.5. So here, the relative frequencies here would be 22%, 18%, 12%, 8%, 2%, and 2%. And on the left-hand side of the peak, 18%, 10%, 4%, and 4%. So here, each of these tick marks on the vertical axis would represent 2 percentage points. So notice I've got the relative frequency table, but more intuitive is the histogram representing this relative frequency table. And if you look at this histogram, it's got the classic bell-shaped to it. Now let's make some notes about this particular relative frequency table and the histogram. First of all, the relative frequencies all add to 100%. The most frequently occurring class is going to be class of IQs between 91.5 and 98.5, 22%. And notice that's represented by this part of the histogram here. In fact, the median IQ, if I were to put these 50 data points into a calculator and use one variable statistics, the TI-84 would give me a median value of 96, and notice 96 falls right within the most frequently occurring class. And the mean IQ, so X bar on the TI-84, would give me 96.02, and again that would fall within this most frequently occurring frequency class. So here the peak is going to contain within this data values that are the mean and the median. So in the symmetrical bell-shaped, not only is a peak at the frequently most occurring class, but the median and the mean are both within that particular class. The relative frequencies, here I've got them in terms of percent, but you could have them as decimals or fractions. They're going to represent the chance or likelihood that any randomly chosen person in the sample has an IQ in that class. So for example, if I look at this first class, the relative frequency is 4%. So there's a 4% chance that any random person out of the 50 would have an IQ between 63.5 and 70.5. Similarly, for this class here, from 98.5 to 105.5, there's an 18% chance that any one individual out of the 50 would have an IQ between those two values. So each of these relative frequencies is going to give me the chance or likelihood that any one randomly selected person out of the 50 would fall into one of those frequencies. Also proportionally, so this is a nice use of the visual histogram, proportionally each one of these rectangles area with respect to all of the area is going to represent the likelihood that any random IQ would fall into that particular class. So the area of this most frequently occurring rectangle divided by the total area of the histogram would also give me 22% or 0.22. So the area of the rectangle with respect to the area of the entire histogram is going to give me the same value as the relative frequency. The last thing we want to mention is that we're going to use the term probability as being equivalent to the chance or likelihood of an event occurring. So in this particular example, the event would be the value of our random variable x, and x would be the IQ of a random person within the sample of 50. And so written below here are summarized the 5 things that I just mentioned. The total of the relative frequencies is 1, or 100%. The most frequently occurring IQ class was 91.5 to 98.5, and in fact, the median IQ as well as the mean IQ fell within that most frequently occurring IQ class. Therefore, the mean, the median, and the mode, here the mode is the most frequently occurring IQ class, are all roughly the same. The relative frequency of each class represents the chance or likelihood that any randomly chosen person in the sample has an IQ in that class. Proportionally, the area of any one rectangle in the histogram with respect to the total area of the histogram represents the chance or likelihood that any randomly chosen person would have an IQ in that particular class. And we're going to be using the term probability as the same thing as chance or likelihood that an event occurs. In this case, in our example, the event would be a random IQ, X, of a particular person or random person in our sample of 50.